Okay, so we're going to talk about dependency management and decoupling for networking service. And I advise you, don't do a technical interview for a senior position before watching this video. So let's get down to it, okay? In our prior examples where I used MVVM and created a view model. In the MVVM object, I created a networking service, right? And basically we got the job done, right? We were able to um access whatever data, parse it, and do all that in the view model. But that was just done for demonstration purposes. What if I told you that that's not how you should be doing it in the real world, right? I just wanted to get you to have a basic understanding of a view model. But what you really want to do is you want to have this decoupled and you want to use a dependency manager. So I know that sounds confusing. I'm going to explain it. So let's talk about what are the cons in the Swift language of a view model creating instance of a networking service. Okay. So there are a few potential downsides to having, to having a view model create an instance of a networking service directly, as opposed to using a dependency manager. Number one, tight coupling. If the view model creates an instance of the networking service directly, it is tightly coupled to that specific implementation of the networking service. This can make it difficult to swap out networking services for a different implementation or mock the service for testing purposes. I'm going to show you about that if that doesn't make sense to you now. Lack of reuse. A view model that creates its own networking service may not be able to take advantage of any other networking services that have already been created and are being managed by a dependency manager. Okay. 3, increased complexity. Managing dependencies through a dependency manager adds an extra layer of indirection, which makes the code base more complex. This can make it more difficult for developers to understand the relationship between different components in the system. So overall, using a dependency manager can help reduce tight coupling and increase code reuse, but it can also add complexity to the code base. Whether or not it is the right approach will depend on specific requirements for your project. That being said, I'm going to say that in the real world, um, developers, mid to senior level developers tend to lean towards network managers and a level of decoupling, of decoupling one object, in this case, a network service, from another object, in this case, the view model. So if that doesn't make sense, let's go more into it, right? So I'm going to give you a decoupling illustration, right? We're going to use superheroes, Marvel superheroes, the Hulk and Iron Man, right? And when the Hulk receives his powers, right, Bruce Banner was affected, right? So basically, when Bruce Banner was hit by the gamma rays back in the day, it affected Bruce Banner. So just say hypothetically, if you wanted to augment Bruce Banner's powers or the Hulk's powers, or maybe take something out using gamma radiation, you're going to affect Bruce Banner, right? You can't make any type of augmentation or change to the Hulk without affecting Bruce Banner. That's an example of his superpowers being coupled to him. Tony Stark and Iron Man, on the other hand, you can make changes to the armor without affecting Tony Stark. You know what I'm saying? You take off the armor, you can even swap armor on Tony Stark. So yeah, That's an example of decoupling. Iron Man, on the other hand, can add features to his suit that have no effects on his actual body. Iron Man and his suit are separate entities that can be modified and changed without changing the other. And the same thing goes for objects. In this case, networking service in your view model. What you want to do is to be able to implement your networking service, but you don't want it tied to the object, right? In our last examples, that's what we did. Now here's another example of decoupling, right? So you have an object, right? One object is a War Machine object, and the other one is an Iron Man object, right? And they are connected to their powers by a method, fetch flight capability, right? And an array of feature objects are returned, right? Well, here it is. Well, they aren't returned. They come from the escape enclosure, right? Will return is void. But anyway, and if you notice, you have this class, War Machine, and what it implements the armored suit protocol. As a result of implementing the armored suit protocol, you have this function, fetch flight capability, right? And of course, because it's War Machine, your implementation may be different than if it was Iron Man. But you can swap out different features. In this case, it's Iron Man. This case, it's War Machine. But you're not affecting the other aspects of the class, right? Okay. And here's another example right here where you swap it out, right? You have your class. Instead of making this of type War Machine, right? You're going to make it armored suit. Instead of making this of type Iron Man, because this could be of type Iron Man, you make it of type armored suits. And both of those conform, War Machine and Iron Man conform to armored suit, right? So when I implement this, right, I create a variable that's going to be a War Machine, right? It's going to be a War Machine, but I make it armored suit when I declare it here. But when it's instantiated, that's when I say War Machine. But I could swap this out. Instead of saying War Machine, I could say Iron Man, right? So that's how you have it decoupled. This doesn't have to be when I declare it here, the instance doesn't have to be a War Machine or an Iron Man. You can pick, right? And you can swap them out at later times in the development process. And we're gonna touch upon a version of that type of thing when we talk about mocking and stubbing. Okay. Okay. So now we have that. And what we're going to do now is we're going to move on to our practical example in code in the next video. So on to the next.